Okay, so hopefully you found the right video. This is Algebra 1 chapter review, and this is chapter 5 review. All right, I see that's not on there, and that's really, really important. This is Algebra 1 chapter 5 review, and it's basically going to involve Cartesian planes, relations, functions, vertical line tests, graphing relations, graphing functions, graphing absolute value, and then direct and indirect variation. Again, this is a quick review designed that you'll just watch, and I'll try to cover as much as I can in as quick a time as possible of chapter 5 review. All right, here we go. Okay, so first thought here is let's make sure that we understand our Cartesian plane. Remember, it can be called a Cartesian plane or a coordinate plane or a rectangular coordinate plane. Horizontal axis is the x-axis, right? Horizontal axis is the x-axis. The vertical axis is the y-axis. Right, that's important. I'll mention that again in a moment. Now, the axis breaks up your area into 4 quadrants. The upper right is quadrant 1, the upper left is quadrant 2, lower left is quadrant 3, lower right is quadrant 4. It also gives you a 0, 0 point, and don't forget that's called the origin. The origin. Now, every point can be located by its coordinates. The coordinates are an ordered pair. An ordered pair meaning there's order. So let's do a point A here. So point A has an x coordinate of 4 and a y coordinate of 1. Right? Remember, we always put coordinates in parentheses. This is an ordered pair, meaning the x coordinate, the horizontal change from the origin always goes first, and then the y, the vertical change from the origin always goes second. So if you look at point B again, you want to figure out the horizontal part first. That's a -3. And then you want to figure out the vertical part, and that is a 4. Again, x first, y second. Okay, I'm not going to do the rest of the points there. Now, what if they told you to graph something like -5, 1? -5, 1. So you have to understand that this first coordinate is the horizontal coordinate. -5 is left 5. And then a +1 is up 1. And my point is right there. And I don't know, let's suppose it was point T. So I'll label it with point T. Okay, so easy parts on a coordinate plane or a rectangular plane, or against a lot call it a Cartesian plane. Okay, what if you had a problem like this? -8, 15. So let's suppose you have the point -8, 15, and you want a point that is 4 units left and 3 up. Now, this is a real simple problem. You could actually, if you wanted to, graph it on a Cartesian plane, but there's no need to do this. And by the way, my Cartesian plane isn't even big enough for it, right? It's not. Well, look, 4 units left. Left and right is the x coordinate. Left is negative, right is positive. So that's a -4 in the x coordinate. And so 3 up and down is a y, and positive is up, and negative is down. So look, if I take the original point, and if I do the x and y change to it, I need to go 4 more to the left. I'm at a -8. I end up at -12, right? I'm just adding. -8 and -4 is -12. I'm at 15. I got to go 3 up. I'm at 18. That should be an easy problem and no sweat. Pretty easy to handle. All right, Cartesian planes, coordinate planes. Don't forget the x is the horizontal and the y is the vertical axis. All right. Number 2 here. Let's see if I can get high enough. If my screen is going to cooperate, and it is. Okay. Remember, in the aspect of a relation function. What is a relation? A relation is when everything is paired. If all members of the set are paired, then it's a relation. -1 is with 0, 2 is with 4, 3 is with 4, and 5 is with 7. Everything is paired. That is a relation. Now, is it a special relation that we also call a function? Maybe. A function is when every x coordinate has only one y coordinate. In other words, any input has only one output. So I like to say the X's are the guys and the Y's are the girls. And so simply put, what is a function? If any guy can date only one girl. Who is guy -1 dating? Girl 0. Who is guy 2 dating? Girl 4. Who is guy 3 dating? Girl 4. Who is guy 5 dating? Girl 7. Is any guy dating two girls? And the answer is no. And if the fact that any guy is not dating two girls, then it is a function. So this is a function. Boy, that's lousy writing, but you get the idea. Okay, now we can ask you to go ahead and show a function or a relation four different ways. First way is with an XY chart. Pretty simplistic. You need to list the X values. And by the way, each X value forms a set called the domain. And each X is an abscissa, right? Some terminology. And then you have to go with who's the -1 paired with? The 0. Who's the 2 paired with? The 4. Who's the 3 paired with? The 4. And who's the 5 paired with? The 7. All right, so that is representing the function as an XY chart. Number 2, how would you represent the function, oops, don't let me go too high, as a set notation? Well, it's actually the way it's initially listed. This is set notation in that we're listing the pairs as a set. 2, 4, 3, 4, and 5, 7, and that's how you would list it as a set. Third way is we could ask you to graph it. We could ask you to graph it. Oh, ugly writing today. I'll tell you, I got to get rid of that. I'm trying to do this fast and I'm going too fast, and that's sometimes an issue. So let's graph the function. Okay, the easiest way to graph is off of an XY chart. Again, you can do it off a set notation as well. You're simply graphing the pairs. So -1, 0. 1 to the left, and don't go up or down. All right, there's that first point. Second point, 2, 4. 2 to the right and 4 up. Right there, right? 2 to the right and 4 up. 3, 4. I'll show you this one. 3 to the right and 4 up, right? So 3, 4 gets you there. Let me get rid of my marks there now. 3, 4. And finally, the last one is 5, 7. Go 5 to the right. And I have to go 7 up. Now I got a problem. My graph ends here at 5. Not a big deal. I'll draw in a 6 and I'll draw in a 7, right? Not a problem, so that I can put that point right where it belongs. Okay? So we graphed it by graphing the points. And you might say, well, how do I know when to connect the points? Well, whenever the function is just simply a set of points, then that's all it is a set of points. All right, the fourth way to represent this is as a mapping diagram. Remember, I asked you to label domain and range either on top of each of the sets or down below. I'm doing mine on top. You could also do it below. What is the domain? The -1. These are all the guys, right? All the X values, the 2, the 3, and the 5. What is the range? The 0, the 4. Remember, you do not repeat anything twice, and the 7. And don't forget to map the abscissa to its ordinate or image. So -1 is with 0. 2 is with 4. Make sure the arrow goes from the independent, the input, the abscissa, to the ordinate, the output, right? And then 5 is dating 7. And there you go, a mapping diagram. Okay, is a graph just a relation or is it also a function? Remember, this is called the vertical line test. The vertical line test. And what is the vertical line test? Is if you can find a vertical line, if a vertical line exists that will hit 2 or more points, then it is not a function. It is just a relation. Now, here's the thing on this first one. No matter what vertical line I choose, I only hit 1 point. Okay? Therefore, this is a relation, but more specifically, it is a function. It passed the vertical line test. All right, second one. Is that a function or just a relation? Function or just a relation? Well, you should say just a relation. And And you can see that it fails on this vertical line, hits 3 of the points. So again, if it hits 2 or more. And what's the problem? For a -1 input, there are 3 possible outputs. A 1 output, a 3 output, and a -2 output. And that's a problem. Because remember, we want to input, we want to get a definite output, and we can't. If you input -1, we don't know what to give you. We don't know whether to say 1 out, 3 out, or -2 out. And that would be a problem. If that were a computer program, you would have issues. Okay, third situation, we have a line. Remember, the line is made up of consecutive points. So this line is nothing more than a bunch of points, right? So again, does a vertical line exist that will hit more than 1 point? And the answer is no. And if the answer is no, it is a function. If it only hits 1 point, then any guy is dating only one girl. It is a function. Let's look at our last one. By the way, what kind of function is this, or what kind of graph is this? Absolute value. And is it a function? Well, indeed, no matter what, whoops, that was great. No matter what vertical line you choose, you do only hit it at 1 point, no matter what vertical line you choose. So it would be a function. Okay? The vertical line test for functions. Lots of other shapes. Those were the ones I chose there. Okay? All right, let's go ahead and deal with graphing. Graphing linear functions. All right, go away, Windows. Thank you. And get this higher for your benefit. Okay, so let's take a look here at number 4. Let's graph. So what do we have? We have set builder notation. Let me read this for you. This is a set of all xy pairs such that y equals -2x plus 1, where x equals -1, 2, and 3. This part right here is the rule. It's really what you're graphing. The red part, x equals, is telling you the domain. Now you got to ask yourself, when I graph this, am I going to get a bunch of points or am I going to get a line? And you better realize that this is a bunch of points. The reason, our domain is only -1, 2, and 3. We only have 3 guys. -1 guy, 2 guy, and 3 guy. And that's it. So this is just going to be 3 points. How do I graph it? I do an XY chart. First off, I need to use guy -1. And remember, you're just putting it into the function. Y equals -2 times my x plus 1. And what is my x value? A -1. So, -2 times a -1, doing right here, is a +2. +2 plus 1 is a +3. And I get the point -1, 3. Let me graph it. From the origin, go 1 left and go up 3. Right there. And there's that point. All right, I'm also supposed to use 2 as the domain. So again, y equals -2, parentheses where my x is. Stick in my 2. Again, a -2 times a 2 now is a -4. A -4 and a +1 is a -3. So I have the point 2, -3. 2 to the right and 3 down, right there. And now I need to do the last of my domain, which is a 3. And again, y equals -2 times parentheses for the x plus 1. And this time our x is a 3. -2 times 3 is a -6. And -6 and a +1 is a -5. And I have the point 3 to the right and 5 down right there. Do I put a line through them? No. Because I only have guy -1 and he's dating girl 3. I only have guy 2 and he's dating girl -3. And I have guy 3 and he's dating girl -5. Okay? It's just the 3 points on that graph. If they would have given you 4 values of the domain, you would have 4 points. If they give you 8 values of the domain, you would have 8 points. All right, so let's look at the next situation. And you can see it's a little different. Set builder notation again. This is a set of all xy pairs such that, and again, here is your function rule right here. This is what we're graphing. Now, when no domain is given, what is the domain? We learned this in class, and hopefully remember it's all the real numbers. Is this going to be a bunch of points or is it going to be a line? This is going to be a line because all guys are available. Every guy is dating some girl, and we need to represent it with a line. Okay, how do we figure out where the line goes? Again, an XY chart. That usually allows X to be first and Y second. Okay, now here, it doesn't say what to use. And really, I get to choose. So I can use anything I want for the domain. I'm going to use 0. 0 is always a great value to use. So once again, y is going to equal 3 times x minus 4. And where the x is, I'm going to put in 0. Again, you see I'm getting this from the function, right? So 3 times 0 is 0. 0 minus 4 is a minus 4. I have the point 0, negative 4. So I go to the origin, I go down 4, and I put that point, 0, negative 4. All right, I can do any point I want. I'm going to do 1 next. The smaller the number, usually the easier, and your Cartesian plane doesn't have to be that big. So again, this time I'm subbing in 1. 3 times 1 is 3. 3 positives and 4 negatives is 1 negative, and I have the point 1, negative 1. Now, any 2 points determine a line, and I could draw my line. The problem is if I made a mistake, I would never know it. So I advise always to do a third point. I'm going to do a 2. Again, y equals 3 times the x minus 4. Let's put the 2 in for the x. 3 times 2 is 6. 6 positives and 4 negatives is 2 positives, and I have the point 2, 2. Now, if you're correct, all 3 of your points will line up in a line, and don't forget this is a line, and therefore we've got to draw a line through it. Arrows on both sides, meaning that this line goes forever down and to the left and forever up and to the right. Okay? So graphing linear functions. First one, a definite domain. It's just the points. Second one, no domain given. Domain is all the real numbers. You get a line. Okay. Direct and indirect variation. All right. Or direct and inverse variation. You need to be careful. You could also talk, these could also be called directly proportional and inversely proportional. So this thing says to write the function rule. So you have to have in your brain that the function rule is y equals kx, and all I need to do is put in the value for k. So that's my pattern, y equals kx. I need the value of k. Now how do I find the value of k? Well, I also use y equals kx to find the value of k. Where the y is, I'm going to put in its value, and where the x is, I'm going to put in its value. What's the value of y? It's a 10. I'll put it in where y goes. What's the value of x? It's a 4. I'll put it in where x goes. How would I solve this like any equation? I'm going to isolate the k. I'm going to divide both sides by 4. And don't forget, you're going to reduce this, and hopefully you see that that reduces down to 5/2. And so k equals 5/2. So how do I found the value of k? How do I now write the function rule for this direct variation? I simply go where the k is and I put in the 5/2. That's all I need to do. Now, instead of me saying the problem like this, I could have given you a bunch of xy pairs. Okay? I could have given you 2 and 10, or 4 and 10. I could have given you 2 and 5, 4 and 10, 6 and 15, etc. And again, you could use any pair, that's the pair I used, to figure out the value of k and sub it in and write the function rule. Okay? But look, you got to know this, that y equals kx for direct variation. You have to know that. And then all you need is the value of k, sub it in, and you're done. So let's take a look at our inverse proportion, or varies indirectly. Same idea, a little bit different wording. Well, in this one, again, you have to remember and have to know the correct function rule. Well, for an inverse, it's y equals k divided by x. And again, all I need to know is the value of k. How can I find it? Again, I can sub in the value of y for where y is and the value of x for where x is. What is y? A 5. What is x? A 3. Let's solve this little equation. Okay, let's multiply the left by 3 over 1 and the right by 3 over 1, right? So all you got to do, so what do we end up with? In this case, 15 equals k. How do I finish writing the rule? Go back to that pattern. Put the 15 where the k is. There's the function rule for inversely proportional. Now, let me just stop and remind you of one thing. Things that are directly proportional. Notice as the x increases from a 2 to a 4, from a 4 to a 6, what does y do? It increases from a 5 to a 10, from a 10 to a 15. That's directly proportional. You could also have it as x decreases, y decreases. That's directly proportional. What is inversely proportional? As one increases the x's, the other one decreases the y's. Or as one decreases the x's, the other increases the y's. That's inversely. So directly, if one goes up, the other goes up. If one goes down, the other goes down. Inversely, if one goes up, the other goes down. If one goes down, the other goes up. Okay? But you got to know your patterns. So make sure you have those memorized. Don't miss those. Okay, sequences. So we take a look at this sequence here, and I'm looking right here now. And I have to understand what's given here, and I have to understand this is the explicit formula. From this, I therefore know the first term is right here. It is the coefficient or the multiplier. I also should know that the base of this exponent is the value of r. So I know that r is a 5, and I know that the first term is a -2. If they want me to list the first 4 terms, the easiest way now is list the first. And remember, a geometric sequence, you can find the next term by multiplying what you have by r. What's -2 times 5? -10. What's -10 times 5? -50. What's -50 times 5? -250. There are the first 4 terms. So as long as you know the first term and you know r, it's easy to get the first 4 terms or 5 terms or first 8 terms or whatever. Okay? But again, you have to know what is the first term from the form they gave you and what is the value of r. So it is important that you know those if you're going to be able to do that type of problem. Okay, here's a second situation. What if they say find a sub 11? So hopefully you're thinking, oh, that means I need to find the 11th term. So I'll really just use this formula. A of 11, the 11th term, is the -2 times the 5 to the n. What's it? The n? 11 minus 1. So a sub 11 equals a -2 times 5 to the 10th power. Now remember, you got to evaluate all exponents first. So you've got to figure out the value of this. And so you punch it out in your calculator, and your calculator tells you that 5 to the 10th power is some big number. And I don't have it written down here. Let me punch it out real quick for you. So 5 to the 10th is a million something here. 5 to the 10th. And remember, we went over these buttons in class. And this is 9,765,625. Finish it off by multiplying by 2. You're doing all this in your calculator, and you end up with a sub 11 equals -19,531,250, right? And so you're just punching that out if you understand geometric sequences. Okay? All right, what else? Let me go higher here, move that out of the way. All right, what if they give you an absolute value function, and you know it's an absolute value function because you see the absolute value symbol? What if they asked for the coordinates of the vertex? So we learned this on Tuesday. Remember the pattern. So let me write it out for you. Y equals the absolute value of x minus, and then comes the value of h, and then comes plus k. And remember, the vertex coordinates are always h is the x coordinate and k is the y coordinate. So according to this, what is in the spot of the h? And hopefully you say the 8. And what is in the spot of the k? And hopefully you say negative 21. What is the vertex? The point at 8, negative 21. We'll look at a couple more aspects of that on the next example. All right, so here, number 9, we got a graph. And wow, this is getting long, so I got to go here. We got a graph y plus 2 equals x. Okay, I look at this and I say absolute value. I should immediately think any absolute value has a V shape. You better think that or you're going to miss these. Okay, I need to move that 2 to the other side to get this in proper form. So y equals the absolute value of x minus 2. Now it's best if I figure out the vertex coordinates. What is the value of h? There is none. What is nothing? Nothing is 0. What is the value of k? Negative 2. So my vertex is 0, negative 2. I'm going to plot that point. It's right there. Now I need to use an XY chart to figure out a point to the right of my vertex and a point to the left of my vertex. Okay, I'm going to use an x coordinate of 1. That would be a point to the right of my vertex, right? To the right of that. How do I figure it out? Same way. I do my function, and where the x is, I'll put in negative 1. So watch. The absolute, or no, not negative 1, 1, excuse me. So the absolute value of 1 is 1. 1 positive and 2 negatives leaves me a negative 1. And I have the point 1, negative 1 right there. Okay, I already know that the right-hand side of this goes like this now. Because I know the vertex is 0, negative 2. Now I need a point on the other side. I'll do negative 1. Again, the function. And where the x value is, I'll put in negative 1. What's the absolute value of negative 1? It's 1. What's a positive 1 and a negative 2? And negative 1. And my point is at 1 left and 1 down and right there. And I know the other side then goes off like that. And I've graphed that absolute value. Okay, what about something like this? Again, you look at it and you see y equals the absolute value of x plus 3 plus 1. By the way, maybe they'll do f of x on you, right? Don't freak out. It just replaces the y. Now in this one, what's the value of the vertex? Well, let me write it in proper form. If I were to write it in proper form, this would be minus a minus 3. Do you see now how the vertex has coordinates of negative 3, positive 1? Be careful with that, right? Remember, the pattern has a negative right here, and therefore then it must have been negative a negative 3 to end up being positive 3. All right, where's my vertex? 3 to the left and up 1. So it's right there. Whoops, it is 3 to the left and up 1 right there. Okay? XY chart. Now pay attention here. Notice I'm already at an x of negative 3. I'm going to go 1 to the right to an x of negative 2. So I'm going to use negative 2 for my x. Take your original function and where the x is, right there, put in your negative 2. Remember, do what's inside the absolute value first. Negative 2 and a positive 3 is a 1. Absolute value of 1 is 1. 1 plus 1 is 2. I get the point negative 2, 2. 2 to the left, 2 up. Again, I understand the right-hand side of my v is like that. I'm going to go one value to the left now of negative 3. I'm going to go negative 4. Again, I'm going to go y equals the absolute value of x plus 3 plus 1. Stick in my negative 4. 4 negatives and 3 positives is 1 negative. The absolute value of negative 1 is 1. 1 plus 1 is 2. The point negative 4, 2 is right there. There's the other side, and there's my V shape. Okay? Graphing absolute value. You're going to have to do that on the test, so make sure you're ready for that. Okay, one last thing here, and I know I've taken some time. Last thing here is domain and range. All right? So here I have the graph of a function or relation. Which would it be? Is this a relation? Is it just a relation or is it also a function? Hopefully you say this is just a relation because this part fails the vertical line test, right? So it's just a relation. All right, domain. Remember, domain are the x values, right? All the abscissas. It's the input. So I'm looking at the horizontal x-axis. What is the lowest x value? It is negative 5. I'm going to put a point there. What is the highest x value? It is positive 5. And don't I have every x value in between? I do. So how do I say every point from negative 5 all the way up to and including 5? Do you remember how to do that from conjunctions? So our domain is going to be negative 5 less than or equal to x less than or equal to 5. Right? Start on the low end. Always do less than or equal to. The dot is less than or equal to. Circle would have been less than. Go to the highest value, right? Less than or equal to x, less than or equal to, and then the 5. What about our y values? Let me do y on the vertical axis. What is our lowest y value? Always go lowest first. It's at negative 3. What's my highest x value? It goes on forever, right? Doesn't this thing keep going up forever? It does. So how do I say values that are bigger than or equal to negative 3? Well, my range will be y greater than or equal to negative 3. And that's how I would say the range on that one. All right, it took a little longer than I thought, but it's a help to you if you want to get prepared for the test. Have a great night.